Everybody, just want to welcome you to week 7, module 7 for ME 171 Design of Elements. So this week's going to run a little bit differently. Your Tuesday class, there's not going to be a live lecture. This is going to be dedicated to the ME 144 exam time, but I have put up a remote recorded lecture for you guys where we're going to finish up our chapter 4 material, in particular looking at pure bending relating back to your ME 14 class. These are topics that we need to cover again, some governing equations and theories that are going to be important and relate to chapter 4 within this course here. Now we're also going to start in the second module 7.2, chapter 5, taking a look at elastic strain, deflection, stability. So some bookkeeping items for this week. We've got a lot going on. You have your quiz number 7. This is going to be due on Friday the 19th by 4 p.m. You also have your white paper that's going to be due this week. So pay attention to the due dates here. So this is going to be due the end of the week on Friday, March 19th at 4 p.m. and it is going to be released on Monday the 15th at 6 a.m. So you've got the full week to work on that. This is something you should have been thinking about for the entire semester. I've also set up all the groups through Blackboard. So this will be a group submission. You won't need to submit this individually. Just one member from the group will submit this through the group submission on Blackboard. So as long as one of your groups submits that, you're all set. Also, you have your homework number 3. This is an individual submission. This is going to be released on Monday, 6 a.m., and it'll be due the following Monday by the end of the day. Now, just a reminder, I do have office hours scheduled for Thursdays from 11:30 to 12:30. This is after our lecture. Now, if these times don't work for you, please send me an email or a message or chat, and we'll find a time that does work. Also, a reminder that the TA does have office hours as well, and these are on Wednesday from 10 to 11:30 a.m. So please take advantage of those if you have any questions related to exams, homeworks, grading, or things like that as well, or concepts. So for module 7, what we're going to do for the first part of it is, again, go over pure bending, finish up chapter 4 and talk about the theory of that, relate it back to what we learned in ME 14, and then we'll move on to chapter 5 and take a look at elastic strain, deflection, stability. So in this module, we're going to analyze the stresses and strains of prismatic members subjected to bending, and also of prismatic members that are subjected to equal and opposite couples acting in the same longitude. And then we're going to consider elastic strain, deflection, stiffness, and stability, which these are areas of very much importance to the engineer. So within this module, some objectives we have right here: take a look at pure bending loading, review some of the stuff we saw in ME 14, go over some of the governing equations and theories, talk about the design for deformation, look at strain energy, external work, and take a look at this theorem here as well. So we're within this is going to relate back to chapters 4, the rest of that reading section there, 5 through 14 for the sections, and starting and finishing chapter 5, sections 1 through 14. So as we take a look at module 7.1, we're actually going to break this into 2 sections. This is going to be 7.1a and 7.1b. So 7.1a and 7.1b are going to be the review of pure bending relating to chapter 4 in this textbook here, and relating also back to your ME 14 course. So this is going to cover the topic of pure bending here. Again, there's no live lecture for that Tuesday. This is going to be the time dedicated for the ME 144 exam. I know many of you in this course are also taking that course. So this time is going to be dedicated for the students taking that. And this will be given during our class time for ME 171. So instead of a live lecture, what I've done is I have some pre-recorded lectures on pure bending. So we're going to talk about deformations, composite materials, stress concentrations, and then the next part we're going to look at plastic deformations, eccentric axial loading, and composite materials and stress concentrations. So within this here, we'll go over the theory, talk about some of the governing equations, some practical applications, and go through some actual problem solving as well. So as I mentioned, we're going to break this into two different sections for module 7.1. So 7.1a, we're looking at pure bending for deformations, composite materials, and stress concentrations. So within this, we're going to consider the general principles of bending behavior, define the deformation, strains, and normal stresses in beams subject to pure bending. Then we're going to describe the behavior of composite beams made of more than one material, so that would be the composite part of it there, and then review stress concentrations and how they are included in the design of beams. So again, with this here, go through the theory, governing equations, applications, and into some problem solving. So for the second section of module 7.1 here, we have 7.1b, still with pure bending, looking at plastic deformations, eccentric axial loading, composite materials, and stress concentrations. So within this section, again, break this down into plastic deformations, elastoplastic materials, eccentric loading, axial loading, stresses, axial and bending, and then take a look at what happens with some unsymmetric bending as well. And again, going through our theory, governing equations, practical applications, and then going through some problems together. So from there, we'll start chapter 5 again. And this is when we'll relate back to our live lecture again on Thursday. And this is where we start chapter 5 in our textbook and talk about the elastic strain, deflection, stability. And within this here, we're going to talk about designing for deformation, strain energy, the external work, and then take a look at the theorem as well. Now within this here, again, still going through the governing theories for all of these, talk about the key equations related to each one of those topics, go through some practical applications, and then get into some problem solving and hand solutions for these as well.